Hey y'all, in this video we're going to get into something that I've gotten a few questions on here lately, and that is tapered ball nose bits. And the big question I get is, do I have to use a tapered ball nose bits for 3D carving? Can't I use just a standard ball nose bit? Well, the short answer is, yeah, you can use a standard ball nose bit for 3D carving. The long answer is, there are a lot of things to take into consideration. There are some situations where you wouldn't want to use a standard ball nose bit. And in this video, we're going to discuss it. So first, we'll go ahead and we'll zoom in. We'll get a little bit closer view at some of these. And I'll give you a little bit of an insight as to why you would want to use a tapered ball nose. Then we'll go inside, get on the computer, and we'll look at a couple of models. And I'll show you some examples of what I'm talking about when I say you might want to use a tapered ball nose and why. Then we'll get into some tool pathing strategies, and I'll explain why I tend to use raster strategy versus offset, and when you would want to use one over the other, and some things to watch out for if you decide to use one over the other. So let's go ahead and zoom in here tight and we'll take a look at some bits. Okay, I have here a small selection of the ball nose bits that I have. These are obviously tapered ball noses and these are standard ball noses. The main reason for a tapered ball nose is this extra length of tapered cutting surface. Now, if we take a look at my 1/16 inch standard ball nose, the cutting length on that cutter is only 1/4 inch. So that's as deep as that bit's going to be able to cut. Now on this 1/16 inch ball nose, however, I've got all this cutting surface up here. This is going to clear away any part of the material that may be overhanging and possibly getting close to hitting this shank here. So if I'm cutting something that's very small and very detailed, and I'm only going to be going maybe at the maximum 1/8 of an inch deep, then yeah, I can use a standard ball nose. In fact, this one over here is a 3/64 inch diameter tip, and this is good for engraving photos, things of that nature, where I'm not going to be cutting super deep. But if I'm going to be carving dishes or domes or some of the more intricately designed 3D models, I'm going to want this extra cutting length up here to be able to allow that tip to plunge down further into the material than just 1/4 of an inch. And this cutting edge up here is going to clear away any overhanging edge, like so, so that that bit can come down in here and carve, should it need to. Now, another question I get quite often is, can I use a standard ball nose to 3D carve? Yes, you can, but you need to keep a few things in mind. First of all, you're going to want to cut a 3D roughing toolpath first. Because again, depending upon the depth of that model, you may have to try to plunge deeper than your cutting edge length will allow. So you'll want to do a 3D roughing toolpath first. Second, you're going to need to make sure that there's enough room for your bit to get in there and do the carving it needs to do without getting too close to any overhanging sides. That may sound confusing, but when we get in on the computer, I'll show you what I'm talking about. So, the optimum bit to use for 3D model carving is a tapered ball nose, but it can be done with a standard ball nose bit. Just make sure you do a roughing toolpath first, and make sure that you're not going to be cutting deeper than your ball nose bit's cutting depth. Now outside I said that if you're carving something that may have a sharp overhang or a steep overhang that might interfere with the cutting edge of the bit or interfere with the shank, you should probably go with a tapered ball nose. And I'm going to give you a couple of examples of what I'm talking about. Here we have this cantering Arabian horse, which I got out of the Vectric clip art library under animals. It's this one right here. And it's in a fairly large piece of material. This is 12 inches wide in X and 10 inches high in Y. So it's a fairly large 3D model here. If we come over into the modeling tab and take a look at the properties, it's got a model depth of 0.724. That is way beyond what the cutting length of any of my standard ball nose bits. So I would want to go ahead and use a tapered ball nose bit. And it's just simply, let me look at the 3D view here, it's just simply because of areas like this, up along the back of the animal, where we have not a real steep 90-degree incline here, but it's fairly steep. So we'd want to use a tapered ball nose because the shank of that short cutting length bit might end up rubbing against one part of the back here. And the same thing down here on his belly. So a tapered ball nose would fit down in here where a standard ball nose may or may not. Now, having said that, it also depends upon the model size. So let me go back to a straight Z view here, and we'll check the model size, and we see it's almost 6 inches wide in X. So let me go ahead and let's go ahead and scale that down. Let's make that about 2 inches wide in X. We'll hit apply, close that. I'm going to move this up here so that it's out of the way. Now we'll take a look at the properties, and we see it's just a little bit more than 1/8 of an inch thick. So we're not over the length that small 3/64 bit, for example, could cut. So the size of the model also will dictate which bit to use. And in fact, with a model this small, that 3/64 bit might be the one to use. So that helps us out on that category. But if we come back over here into the clip art and we look at something like this cantering Arabian that's set in a deep relief that looks like it's been carved, we have the same situation. Go back over to the modeling tab and we see that this one here is still 0.4724. For something this large, especially with these steep walls right here, these would most definitely interfere with the shank of the bit. So a tapered ball nose, being able to cut this out here and allow that tapered edge to clear this material away before that ball nose got up here, that would be the way to go. So again, it's also dependent on the model size. As if I select it and go over here, and we see it's about the same size this one was. If I scale it down to 2 inches, click apply, close that, then go into the properties, it's slightly deeper, but still not above that 1/4 of an inch cutting length that small bit would be able to get in here and handle. So why tapered ball nose? That's why tapered ball nose. It's simply that tapered cutting edge will clear away and handle this material to be able to let that tip of that bit get in there and make the cut without the shank of the bit hitting the material and snapping off the cutting edge. Now let's take a minute to talk about tool pathing. I've gone ahead and I've increased the size of my model up to about 7 inches, and the model carving depth is going to be 0.475 inches, so not quite a ½ inch deep. This is a pretty deep, pretty big model. I'll go over here and I'm going to go straight to a 3D finishing toolpath, which is another benefit of using a tapered ball nose. With that longer cutter, it doesn't necessarily need a 3D roughing toolpath. That longer cutting length on that big tapered cutter will clear away this material, and I don't have to do a 3D roughing toolpath. So let's go ahead and go to a 3D finishing toolpath. I'm going to cut the model boundary, and I'm going to go ahead and select my bit. For this, I'm going to come down to my 16th inch tapered ball nose. We'll select that. I'm going to do a boundary offset of 1/4 of an inch, meaning that that bit's going to come out here and carve out to about here, just so I get a nice smooth edge. I've also added a 0 plane so that I know I'm going to have nice smooth edges here. Now let's talk about machine strategy. You'll notice that more often than not, I will use a raster strategy. And that is where the bit will come in, start down here, and start going back and forth, and start machining this way. I do on occasion use an offset strategy, but this is something to be very careful with. It depends upon a couple of things. Number one, have you done a 3D roughing toolpath? Now in this case, I haven't. Second is, what's the depth of the model? Now with this model being 0.475 deep, almost a ½ inch, what this means is, if I was to use an offset toolpath, that means the bit's going to come over here and it's going to plunge into the depth of this model and start carving in a circle. Now, even though that's a 1/4 inch shank and it's a pretty robust bit, it's still a 1/16 inch cutting depth. And tool breakage is a possibility. So if I absolutely had to do an offset toolpath, I would want to do a 3D roughing toolpath to hog out most of this material, so I can avoid breaking the tip of my real expensive tapered ball nose bit. That's the main reason for using the raster strategy. The tip is going to carve down in here, but that long tapered cutting edge is going to clear away this material out here. And I don't have to worry about my bit plunging down to the full depth. If I didn't have this horse here and I was just carving out a dish using my tapered ball nose bit, I run the risk of plunging that 1/16 of an inch diameter tip all the way down into this material, the full depth, and it's starting to cut. That may be more than that bit's able to handle. So, better bet is to use the raster strategy unless I absolutely have to use offset. Unless I've done a 3D roughing toolpath first. So, that's why I tend to use raster strategy so often. Easily the most common question I get when it comes to a tapered ball nose bit is, how do I add it to my tool database? Well, there's a couple of ways, and I'm going to show you the easiest that I found to do it anyway. Before we can even get into the tool database, we need to have a file open here, because our toolpaths menu isn't available to us without a file open. So let's go ahead and create a new file, and I'm just going to accept whatever's in here because I'm not going to be actually drawing or designing anything out here. So we'll click OK, and now our toolpaths menu is available to us. So we'll click on Toolpaths, then come all the way down here to Tool Database. Now I'll click on that link, and that opens our database. Now, as you've already seen, I already have a couple of tapered ball nose bits, so I created a category for tapered ball nose bits. The way I did that was come up here to Imperial Tools, because that's the unit of measure I use, and I select it. Then come down here to this icon, Add a Group. Click that button, and you see it created a new group, which I then renamed Tapered Ball Nose. And that's where I put those bits after I imported the tool database. Within this category here of Tapered Ball Nose, I have a couple. Now, how did I get these in there? Well, a couple of manufacturers have really stepped up to the plate here lately, and we're talking mainly Amana Tools and Whiteside Tools. Now, if you go to their websites, let's start with Amana first. You can come into their homepage, go over to Products, then down to CNC Router Bits, and you'll see here they've already created a database of all of their tools for Vectric Software and for Autodesk Fusion 360. That's really going to streamline things a lot. So since we're in the Vectric software, let's go ahead and look at the Vectric library. There is one problem with the Vectric tool file database for Amana, and that is it's huge. If you come down here to download it, it's going to download this one tool database that contains every CNC router bit in their catalog. And you can click this link right here, view a list of tools included in the Vectric tool file. It'll open a PDF, and we're talking 14 pages of tools here. Not every single tool Amana makes is on this list, but every single tool on this list is in the database. And this is 14 pages of tools. Chances are you're not buying every single tool in this database. Now, as it sits right now, there is no way of downloading individual tool database files that I have found. So, that's the one disadvantage with using the Amana tool Vectric database, is you download the entire database. You can't just select one individual bit. Now, Whiteside, on the other hand, they do have individual files. So if I come over here to their product catalog and I look at spiral router bits and come over here to their collections down here, they call their tapered ball nose bits conical ball nose bits. So click on that, and they have two models. That's all they have so far. This is they're both 1/4 inch shank. This one here's got a 1/32 inch radius, which means it has a 1/16 inch diameter tip. This one here has a 1/16 inch radius, which means it's an 1/8 inch diameter tip. Let's take a look at the 1/16 inch diameter. And here we go. It has a total angle of 11 degrees, a 1/32 inch radius, which means that's a 1/16 of an inch ball diameter, and a 2.5 inch overall length. They do have a Vectric tool database file for this individual bit. Now, Whiteside has arranged things so you can download individual tools. You don't have to download their entire collection all at once. We'll remember the part number, which is SC64. We'll go up here to Downloads, and there's the Vectric tool files. We'll click on that, and it opens up this page. Now, you should read this page and read it carefully, because there are a few things that you do need to know. If you come over here to the Vectric tool library link and click on that, it opens up a page that is actually on Whiteside's Dropbox. And you can come down
scroll down until we find the SC64 tool, which is this one right here. We click on that and you get this page here. You'll go to download, direct download. Click on direct download. It'll open up the download dialog. And as you can see, I have already downloaded this tool database file. I've also downloaded the Amana tool file. I'm not going to download it again. You would click save to save it on your computer wherever you want to save it to. I'm going to hit cancel because I've already done that. Now, that's all well and good if you're buying Whiteside bits or Amana bits. But what if you buy a Yonico 16th inch tip diameter tapered ball nose bit? Well, Whiteside will tell you right here, never use the tool file for any bit other than the specified Whiteside part number. I tend to take things like this with a grain of salt. To me, this is the same thing as Minwax saying only use our clear coat finishes over our stains, when we all know we can use other finishes over their stains. These are always starting points. We will make modifications to that tool file. So I have the Yonico page open up here on Amazon. Let's go down here into Aspire and let's import that tool file. Now I have tapered ball nose selected. I'll come in here to import a tool database. I'll click on that icon and I'll scroll, navigate till I find that tool file. Select it, click open. Now, it did not place it in the tapered ball nose category. It placed it right here on the bottom of the list, down at the bottom of the list. So I'll just click and drag it up and place it in my tapered ball nose group. So the first thing I want to do with this is I want to rename it, because this isn't the SC64. We're using that Yonico bit. So here's my title over here. I'll click Edit the Tool's Name Format. So I'll get rid of SC64. And now is when I'm going to look at the dimensions here and get into the information from Yonico. We have a 16th inch tip. It's 5.5 degree included angle and a 1 inch cutting length. So we'll go back down here to Aspire, and the tip is 1/16 inch. And 1/4 inch shank. All right, we do have the 5.5 degree tapered ball nose, and we'll click OK. So all that did was rename it. Didn't do anything else. Now down here, I'm going to eliminate their notes, and I'm going to type in Yonico and then the part number. I will copy and paste. That gives me the part number. Now we're going to follow our diagram down here as we get in and change the geometry, the cutting parameters, and get into feeds and speeds. The diameter D is the shank diameter, and that's correct. It's 1/4 inch. The side angle A is one side. It's not the total angle. It's one side. This is 5.5 degrees. Let's check our bit. This also is 5.5 degrees. So that's set. The tip radius, 0.313. The tip radius is 0.3125. Now, what's going to happen is Aspire is going to round that back up to 313. The number of flutes, we'll need to look. And this is a 4-flute bit. Normally, I do not use 4-flute bits with wood. However, there are some exceptions, and 3D carving bits are the exception to that rule. I will use a 4-flute bit on wood when we're talking a tapered ball nose because we're not removing that much material. Now our pass depth is set right now to 1/2 inch. Just me talking here. I don't like that at all on a 1/4 inch shank bit. I think the pass depth, I limit mine to no more than 1/2 of the bit's cutting diameter. Now, the cutting diameter on this bit is technically 1/4 inch. So I'm going to set this, half of that would be 1/8 inch. I'm going to set it at 0.1. And still, I think that's a bit much. I may reduce that later on. My step over here, because it's a tapered ball nose, I want a very, very low step over because I want that detail. And I usually set it to 8%. Now that's only 0.005 of an inch per pass. But remember, this is a tapered ball nose for detailed 3D carving. Anywhere between 8 and 10% is acceptable. I prefer 8% because on this tiny of a bit, I get a lot more detail with a lot less cleanup. My clearance pass step over, I run conservative, no more than 45% of the bit's diameter. So, cutting diameter that is. Now for feeds and speeds, I'm going to leave spindle speed alone simply because I use a router which I normally have set at 16,000 RPM and I don't really mess with that. So my spindle speed is not controlled by any software. I have to set that manually, so this number to me is irrelevant. Feed rate. Your mileage will vary. This is based on the material that you're using. It's based on the machine that you're using. This is easily one of the biggest questions I get asked about. And people hate it when I respond to them because I tell them all the time, I can't tell you what feed rate to enter here. I don't know your machine. I don't know your piece of material. When manufacturers come up with these numbers, chip load, feed rate, plunge rate, spindle RPMs, it is based on an industrial machine that's capable of moving at speeds most home hobby machines can't achieve. So we need to keep that in mind. There are a lot of factors here. The density of the material you're cutting, the rigidity of the machine you're using, and the type of spindle or router that you're using. I always start conservative. And I do take a little bit of ribbing for this, but I can live with that. I'm going to start at 40 inches per minute. Having said that, that does not mean that I'm going to run this bit at 40 inches per minute. That just means that's what it's going to be calculated at. When I'm outside cutting on a CNC, I'm using Mach 3. I can increase my feed rate on the fly as it's cutting and as I see how it's cutting. So I'll start the toolpath, get that G-code running, and then I'll start bumping up my feed rate. I'm starting at 40 inches per minute. I may end up cutting this at 120 inches per minute. but I'm going to gradually increase that feed rate as I go, and I see how that bit is cutting, whether I'm getting any chatter, and whether I'm getting any burning. So that is my baseline. That's what I start at. Because after all, at the end of the day, this bit still has a 1/16 of an inch tip diameter on it. So we start a little bit gentle. My plunge rate, I'm going to leave it half of my feed rate. I don't have an automatic tool changer, so I'm not going to worry about a tool number. I'll click apply, and all of that criteria has been changed. I can click OK. That tool is now entered in the database. The things to take away from this are, when you go into the tool database, if you import a tool file from any manufacturer, if you are not using an industrial machine, the manufacturer will tell you themselves. The tool files are available as a recommended starting point to assist you in the use of our tooling. Cutting speeds and feeds may need to be adjusted based on your specific application, material, depth of cut, and machine capabilities. Do not take their feeds and speeds as gospel. Okay? You will need to get in here and adjust the criteria for your machine, for your material, and for your needs. That's the easiest way I have found to enter any kind of a bit into the tool database. Unless, of course, you already have a bit of a similar geometry entered in here.
So there you go. Probably more than you ever wanted to know about bits, ball nose, tapered ball nose, or anything else for that matter. Now, I'm going to go ahead and I'm going to put a link in the description to each one of these bits that I showed you earlier. That way you can get a look at exactly what I'm using, what I'm talking about, and you can do some comparison shopping on your own. Now, again, you can use those tool database files for other bits. Just remember, you're going to have to change the criteria based on your machine, the material you're cutting, and your router versus spindle. I'll also put a link to Dave Gatton's new and improved homepage where you can get some information on a Gatton CNC of your own. Now don't forget, today at 3 p.m. Eastern, noon Pacific, I'll be hosting a live Q&A number 10 where we can discuss ball nose bits, tapered, standard, any of the tool pathing strategies or design considerations that I discussed in this video. That's noon Pacific, 3 p.m. Eastern for live Q&A number 10. Now, if you're catching this video after live Q&A number 10 has already come and gone, I'll put a link to it in the description box below as soon as it goes live. That's a good excuse to go ahead and subscribe to my channel if you're not already a subscriber. And if you subscribe to my channel, hit that little notification bell right next to that subscribe button. Then you'll get a notification every time I post a video and when I go live for a Q&A session. So I hope to see you this afternoon, noon Pacific, 3 p.m. Eastern. So I hope you got something out of this video anyway. If you did, please give me a thumbs up. I really would appreciate it. And as always, whether you subscribe to my channel or not, I'd like to thank you very much for taking the time to watch. Y'all take care.